We have been overwhelmed by your response. Many people have posed the Optica question direct to my team and I. They know what we do for them. But what can active leaders in optics and photonics do for us? The answer is simple. By joining Optica as a corporate member, you encourage us to expand our trusted global network and support our new range of services. Get deep insights into what's next for your sector in photonics with free access to over 90 market reports, plus exclusive access to the PowerPoint slides for the in-person meetings. And corporate members get exclusive access to all Optica industry meetings in 2024, including...
If you are an investor in photonics, you'll recognize where I am now. Hello from Frankfurt Messe, which will be the venue for the ECO Conference 2024.
The third Tech Summit in Silicon Valley. The Optica Laser Congress in Osaka, Japan. Plus the Optica Quantum Industry Summit, this time in Bristol, UK. And remember, being a corporate member of Optica also gives you discounted access to many partner events, such as Peak Summit Europe, Driving Vision News, and Peak International.
Hello from Disneyland. 2024 has been very hectic so far, trips non-stop. I decided to take a couple of days off and come to Disneyland with my daughter. But I can't stop thinking about next Tuesday, April 30th, where the online industry meeting is on linear drive optics. You may remember OFC 2024.
And you are all here waiting for an event to start on linear drive optics. And this is a very important meeting for us. Pooja, Dianat, and the entire Optica team have been working very hard since OFC because we understood that was the hottest topic so far in our industry. We needed to understand with all of you what was going to happen on the coming years. So we are bringing together some of the people that at OFC made a strong impact on the linear drive optics and asked them how the entire industry can help them succeed, and at the same time ask them what are the key challenges of removing the DSP from a pluggable in a coherent network. On the next hour and a half, we are going to get very strong discussions, opinions, and technology competition, and this is why I excel. On behalf of Optica, this is Jose Pozo, I am the CTO, and I am really happy to be here today with all of you. I would like to start by telling you that this is not a 2-3 people job. Optica is now 24,000 individual members, 600 corporate members, and we are here to connect you. Our job is to connect companies in our industry, and we provide, as I said before, key market reports and connection between our members. We organize the events only to connect our members. The result of today's meeting has to be for all of you to get in touch with potential partners, suppliers, and customers. I speak on behalf of the Corporate Engagement Council. These are the people who tell us what to do and in which direction to move. And I would like to always thank them for their great approach. I would like to say that this is the third meeting of the Optica Online Industry Series. Write down your calendars, 21st of May, quantum sensing. For many of you who are active in the field of photonics, interactive photonics in the room, write down that date, 21st of May. But today is all about linear drive optics, and this meeting is being attended by about 750 people in YouTube and in Zoom right now. 750 people. None of you paid any money. This meeting is possible because of the support of our two sponsors today. First, I would like to acknowledge OptiWave, the design suite for photonic integration and optical networks. OptiWave, thank you very much for supporting this event. And also, I would like to thank Ajinomoto. You're looking for materials for injection molding, for packaging, for non-thermal conductivity, or for extra thermal conductivity between different materials. Ajinomoto is your supplier. Thank you, OptiWave and Ajinomoto, for supporting this event. This event is our linear drive optics, and this event for most of you who has been the first time you attend this event. It has two groups of companies that come here with vision and with potential challenges for that vision. Today, those companies are Arista, Nubis, Lightelligence, and Axelink, and companies that come to the meeting with solutions to enable that vision. And today, those companies are Keystone Photonics, NLM Photonics, Inolium, and Lightspeed Photonics. Also, today we invited a market analyst and very dear friend of Optica from Fire Reality, Mark Lukovic. These are the people who have been scheduled, but this is just a meeting. This is not a webinar. So all of you, at any time, you are welcome to participate and to tell us what is your vision and how do you address other people's vision. These are the companies that are Optica corporate member and have registered for this meeting. We have made sure that all of you play a role in the supply chain, from big technology to equipment manufacturers, end users, provider of fiber optics, provider for fiber components. These are the Optica corporate members who have registered for this event, and they play a role in the future of linear drive optics. If you are surprised that you registered to the meeting and your logo is not here, this is because you are not a corporate member of Optica. Please make sure you register as a corporate member ASAP. We are building the global industrial network, and it is super important for us to have you on board. If you like what we are doing, there is no better way to support us than to become an Optica corporate member. I would like to also remind everyone that all of you have access to a long list of market reports, so please make sure to go to optica.org/market reports, optica.org/market reports at any time and download all the content there. We have purchased market reports from companies like Joel, Dematis. They are all there for you. Use them. They are for free because you're a corporate member. And I also would like to remind everyone that this meeting is also live streaming YouTube. So let me say hello to the YouTubers in the world. Hello, YouTubers. Thank you very much for connecting to this meeting. If you have any question, read it in the chat and I will read it in the room. And also, please make sure that you register for all the upcoming events. And with this, I would like to also say that this is also valid for the people with me here in the Zoom room. Thank you very much for being here today. We need your questions. We need to make sure that you are interactive, that you are active. Please write down at any time your question in the chat. Please say hello in the chat. This is a meeting for connecting companies. And there is no better way to start than to a person that for some time has been one of the drivers of the industry, all the way from his time at Sun Microsystems, all of them. Many of you know what Spark means. Today with us, opening the meeting on linear drive optics, we have none other than Andy Berthosheim from Arista. Andrew, thank you very much for opening the meeting, the floor, and the attention of everyone doing anything on LPO, on LRO is yours.
Yes, good morning, everybody. Can you see my slides?
Yes.
Okay. So a lot of
If you could go to presentation mode.
Oh, presentation mode. Okay.
Yes.
So a lot of progress has been made on linear pluggable optics over the last year, and a lot of progress is being made with also the formation of the LPO MSA, which was announced at OFC, which has the goal to write a common specification, basically a relaxed specification that allows linear pluggable optics to interoperate from multiple vendors. I should also note here that one of my big surprises at OFC was that literally every major optics module vendors had demonstrations and prototypes of linear pluggable optics and showed interoperability at the show floor for the 800 gig type optics today. So what I wanted to highlight here is the history, of course, is the power saving, which is driving significant interest by end customers. And the results that we'll share with you here are speaking for themselves. But on the power savings were even bigger than what we thought a year ago, where we had identified that on the module level, removing the DSP would remove approximately half of the power. And that we thought at the time would result in a 25% reduction in system power. What we actually measured is a 40% reduction in the system power of a 51.2T LPO switch compared to current 800 gig DSP optics with a 700 DSP. And projecting this forward to the 102.4T generation, this would go up to a 1 kilowatt power reduction in the context of a 102.4T switch. Now, there may be, and this is with silicon photonics, apples to apples. Additional power savings are possible with other modulators, but they would apply, of course, to any kind of optics. In terms of the link performance, so what enables LPO is a high-quality SerDes implementation in the switch chip that essentially allows an end-to-end channel between switch to switch going through both the electrical and the optical domains. Again, a year ago, we had a margin of error of 10 to the minus 4 to 10 to minus 5. With the latest product measurements, we're actually between 10 to the 6 to 10 to the 7 headroom compared to the prefect error rate. So this is an enormous amount of margin, and there's no question that this is a highly stable operating condition. One of the other surprises was that the LPO optics actually had superior OMA performance compared to traditional retimed modules. The theory why that is that if you have a single quantization in the switch DSP, you actually get fewer errors than if you have multiple quantizations of the signals, both in the switch and as well as the module DSP. But it was surprising to ourselves that the symbol error distribution is actually superior. Going to one of the implementation challenges, the biggest challenge, believe it or not, is that the electrical channel loss between the short traces that are the ports that are right in front of the switch chip on the board versus the long traces that are the outermost ports is obviously quite different. And the total difference may be in the order of 13 dB. So that is a very important thing to keep in mind, that the linear pluggable optics has to be able to deal with transmit signals that have this range of attenuation. And it is what it is. This is with printed circuit traces, I should highlight here. If one uses flyro cables, that difference can be reduced. But from a manufacturing standpoint, PC boards are generally preferable. So this is measured data on a 51.2T switch. That's a production product at Arista. This is a photograph of the latest modules that had the best driver, the linear driver chip on the market. And it turns out they actually are TP2 compliant at the optical interface. And again, was a surprise to us that was even possible. But it is conceivable that with the very best driver designs, one can achieve TP2 compliance. This is, in fact, more stringent than what is actually needed for the operation, as I outlined earlier. Another interesting development is there is innovation on these driver chips. There is the idea of adding monitoring capability inside the driver to actually sample the eye and allow tuning. These chips are not in production yet, but I think it makes a lot of sense to make the driver somewhat more intelligent. And the other very important development over the last year was the introduction of the so-called LR optics, which is a linear receiver and return transmit. It turns out the receiver part in an LPO world is actually the easy part. The transmit part is harder, right? And so the LRO uses a half DSP for the transmit. Some people call this half retimed. This, needless to say, achieves full TP2 compliance with all the existing monitoring capabilities, and this will reduce system qualification efforts. There's also significant power savings achieved by the LRO compared to a full DSP. Measured data indicates 9 watt typical for an 800 gig DR8 LRO module. The best number we had on an 800 gig LPO module was 7.5, and this is silicon photonics to silicon photonics. And the traditional DSP optics, depending on the generation of the DSP, is between 13 and 15 watts. So the LRO provides significant power saving as well. And then looking forward to the 100 gig to 200 gig lane transition, as you all know, the 800 gig volume ramp has begun, and it will ramp strongly this year and into next year with a very large amount of volume over the next many years. The 600 gig, the 200 gig per lane will start with the switch chips that support 200 gig per lane, which may be available at the very end of 25, certainly in volume in 2026 and beyond. So one key question people are asking is, will LPO or LRO work with 200 gig per lane electrical and optical? And the analysis so far says this is definitely feasible. Basically, the physics of the end-to-end channels don't really change. The bandwidth, of course, is much higher. What it will require is much shorter electrical traces on the motherboard or alternatively fly-over cables. But the same requirement is actually true for conventional DSP modules as well. So we would expect first prototype demonstrations of linear pluggable optics at the system level. I'm sorry, there were some early prototypes at this year's show, but the first system level demonstrations, of course, have to wait until there's a platform available in either late 25 or in volume in 2026. It may be required to use LRO for 224 gig, which certainly simplifies the channel. Power projections. This is sort of a color chart where LPO in blue is always going to be the lowest. LRO, also significant power reduction compared to, call it the best in breed future generation DSPs and the current in red 7 nanometer type DSPs. And as you can see, for the savings really increase as one goes from 800 gig to 600 gig to future 3200 gig modules, where building a 3200 gig module with conventional current DSP technology is essentially not feasible, whereas with an LRO or LPO approach, it fits in the form factor and the power envelope of a conventional OSFP or QSFP-DD module. And just one line here on 3.2T optics. There is some renewed interest to increase the density of switch systems in 16 channels of 200 gig, which would be a DR16. And this is again the estimated power for these different type of systems, where the LPO and the LRO are clearly feasible, whereas a conventional DSP is not. Again, the attraction here is to get to a 1 U phase-space density in the 1 or 2.4T generation, which matters for high-density AI clusters. So there's, of course, other power savings available, which do not relate to the choice of DSP or LRO or LPO, which have to do with better lasers, lower optical coupling losses, better lower voltage modulators, and so on. All of this is of great interest and so on, and somewhat independent of the DSP discussion. But we hope, of course, that other improvements on the optical engine will come in as well. And we talked about the LPO that was announced at OFC. There's weekly meetings, and I have to say there's very good progress that's being made in characterizing, the spec challenge here. And we hope to get the spec out certainly this year to enable a wide ecosystem of suppliers to build compatible optics. In summary, the LPO delivers very, very large power savings at system level, and the LRO will as well. Not quite the same amount, but still significant enough that there's great interest in these power savings for large-scale AI and other applications. The measured prefect data is outstanding. We have LPO modules that support full TP2 compliance. This does require a bit more power on the driver and is in fact more stringent than what is necessary. 200 gig per lambda, we believe, is totally feasible, and LRO may be required. And we have, of course, the LPO MSA to formalize these specifications. And that's all the slides I had. Thank you very much.
Thank you very much, Andy, for a great presentation. It is great to have you here. It was great to be with you at OFC. Could I ask you right now, in your opinion, from the whole industry, what are the most important challenges that we need to cover?
Yeah, I mean, from an end user perspective, I think it's fair to say that no end user, it doesn't matter whether it's a big cloud or small cloud, wants to be in the optics qualification business. So the real challenge is that the industry has to deliver a fully tested, a fully conforming solution that end users can deploy with high confidence so that there's no issues in the field, if you know what I mean. And clearly, this is more challenging with LPO or LRO than a conventional DSP. However, all the measurements we have taken so far on the next current generation of silicon with the advanced SerDes indicate that there's plenty of margin available. So in the end, it comes down to, in a multi-vendor situation with multiple system vendors, multiple optics vendors, multiple optics technologies, multiple TIA chips, multiple driver chips, right? Can we get to a point where there's a enough margin that people can deploy LPO and LRO with confidence? And we certainly believe the answer is yes, but we're not there today.
There's a lot of people who want to get there today, and the first question is coming from Ahmad Atieh from OptiWeb. Ahmad, please unmute your microphone, switch on your screen, and tell us what's on your mind.
Perfect, thanks. Thanks for the presentation. My question is actually about possibility to use probabilistic amplitude shaping with the modulation on these LBOs. Is it possible? Is it considered?
Was that a question for me? Sorry.
Yeah, the question is about using the modulation. Like you showed the PAM4 like modulation scheme. I'm just asking, is it possible like to apply on top of that a probabilistic amplitude shaping pulsing for this modulation?
Yeah, I mean, this is a theoretical question. Basically, the world we live in is defined by the existing IEEE, Ethernet specs and existing SerDes implementations and the existing TIAs and the existing drivers, right? So what we've demonstrated is it works well with all these existing components, and some of these components, in particular the drivers, can be enhanced. However, making any other assumptions to changes in modulation formats or to further improve, say, the SerDes designs are of course limited to future implementations of these SerDes, which are not available today. So the SerDes is what it is. And the other thing I would like to note here is that all leading silicon vendors have shown at OFC that they can in fact drive LPO optics. Of course, it doesn't mean that all the qualifications are done, but from a high-tech, the current generation of SerDes technology, I think there's no question that the implementations are good enough to have an end-to-end channel. But the rest is very careful system implementation on both the motherboard, the optics modules, the choice of TIAs, the drivers, and so on. So it is not for free, right? You have to do a very careful implementation, but the current evidential experience, suggests that it's really not an issue, but a lot of testing still needs to be done.
Okay, thanks.
The second question is coming all the way from Switzerland, from Neuchâtel. Winfred Noll from Focuslight Switzerland. What's on your mind?
Hello, thank you. I was following the ramp session and other events at OFC, and for me it was not 100% clear if LPO has to be based on silicon photonics, or are there other technologies, modulations possible to do this? Or because when we talk to our clients, so silicon photonics is not as widespread as one might see at OFC. I get the impression, at least from our clients. So this is a question I have here in the audience and also for Andy. So do you only see silicon photonics be an enabling technology for LPO, or are there other technological options, basically?
Yeah, that's a very good question. So linear optics benefit from a linear driver and a linear modulators. So optics technologies that include VCSELs and EMLs that are not as linear have a challenge because the performance of the channel is not as good. Okay, that doesn't mean you can't do it, but you would almost have to like pre-distort or level shift, the signal to address the nonlinearity of the modulation itself. So it is easier with silicon photonics and with thin film light rate, for example. On the other hand, the LRO doesn't have this limitation. So in an LRO world, it's just like today. You can drive, EMLs or VCSELs all day long. So this is actually one of the advantages of LRO is that it's less dependent on the exact optical modulation performance.
Thank you.
We have one more question. We have many more questions, but we have time. So please keep asking. Then the next one is coming from Weihan Huang. What's on your mind? Weihan, please unmute your microphone and tell us what's on your mind. While we solve the IT issue, the next question is coming from Akteb Abu Masbed. Tell us, please switch on your camera, unmute your microphone, and speak your mind.
Thanks, Jose. Unfortunately, I don't have a camera. I'm joining from a desktop computer. So my question is actually in line with the previous question. So we see, trends in, many technologies like thin film lithium niobate, to improve the bandwidth, right, of the modulator. So the question is actually, there's a limitation in silicon photonic modulators, right? So you cannot go beyond certain, and there's issues with loss. So people thinking now about thin film lithium niobate, and the traditional question is that now is the packaging, right? The integration with the silicon photonics. Is there like a plan which integration method will be considered? Is it like hybrid? Is it heterogeneous? What's your view on that? Thanks.
Yeah, so if I can try to answer this, obviously there's many great technologies in development, and people are doing they're working over, very, really hard to get newer technologies into production. What we have observed recently is that end customers, or the large end customers, are getting quite risk averse in terms of their future purchasing plans. Basically, they have to commit to millions and millions of optics, for like deployment next year. And realistically, they want to use technologies that are in volume production, mature, stable, guaranteed to work. And there's lead times, of course, and so on. So whatever they're going to deploy, say by the middle of next year, they have to decide today. And unfortunately, the newer technologies, including thin film light rate, are not at the point of volume production that they actually qualify for volume deployment in people's minds. That doesn't mean that they won't get deployed in some places, but in the volume case, people will remain, as far as we can tell, with the existing technologies that are shipping in high volume, because they don't see a choice.
Mm-hmm. Okay, so you still see silicon photonics, right? Sorry, I'm following.
Yeah, I mean, silicon photonics is proven, right?
Okay.
EML is proven, VCSELs are proven. People will ship. I mean, there's shortages. There's a supply-demand imbalance right now in the market, right? So as people try to ramp up the Ethernet geek supply, they're naturally doing it in the way that they already have the technology in mass production. There's no way around it.
Okay.
Yeah.
Thanks, Sandy.
Thank you very much, Ahmed. And now we go to the United Kingdom, where we are going to meet the CEO of OneVia, Suhas Rattan. You also have a question for Andy. Please speak your mind.
Sure. Hi, it's Suhas from OneVia. Can you hear me?
Loud and clear.
Perfect. Quick question on LPO-based modules. So what regions are they planned to cover? So LR, DR, FR?
Yeah, that's a very, very good question. So the impairment of the optical channel, of course, does increase with longer reaches. And that doesn't mean that it wouldn't work, but the focus of LPO is the 500-meter data center type environment. And some people think the focus actually should be the 100-meter AI cluster, where the power really matters, right? So the goal is not to displace the longer reach optics in any way at all. This is really focused on new applications, the new chips that support the new SerDes. Remember, you need the latest SerDes for this even to work, right? And interoperability with the last generation of optics is actually a lower priority. So the focus is really in the context. What the customer wants is lower power for AI clusters that works. It's really simple, right? And we have had seen good results with LPO. LRO is even simpler to verify, and they will go with one or the other in volume next year. So much is clear for AI. For the rest of the market, just use DSP.
Andy, sorry, Tsuhas, let's move on because we have a few more questions. Andy, you're going to like the next question. It's coming all the way from Ireland. It's coming all the way from Dublin City University. Liam Barry, welcome to the meeting. Tell us what's on your mind.
Hey, okay, thank you. And thanks for the talk. Apologies, obviously, I'm an academic here, so not an industry person. But I saw on one of your slides you mentioned the move from PAM4 eventually to 16 QAM. And I'm just wondering, what time frame do you see these short reach networks transitioning from direct detection to coherent? And do you think the power consumption there is going to be an issue from a DSP side? Can we use dual polarization where we can maybe get like 400G or 800G potentially per wavelength?
Yeah. So this is the age-old question of how far can you push PAM4 in reach as the baud rates go up versus how inexpensive or attractive does the 16 QAM become in say a 1600 gig or future world. And the current belief is that all the data center requirements within a data center and even within a campus setting can be met with PAM4, which is the highest volume thing on the market and likely to be the lowest cost for the foreseeable future. Where the 16 QAM comes in, and I should mention here that the business of coherent optics is growing rapidly every year, and it's a great business to be in. It's a much higher selling price per port and so on and so on. But where it gets attractive is if you're running out of fibers. So in a setting, for example, in a campus setting, if you're not fiber rich between your buildings, and you suddenly want to transfer it, hundreds and hundreds of petabits between these buildings, you may not have a choice but to deploy coherent just because it's too much hassle to dig up the fibers and put in another, 10,000s of fibers. So there are use cases where if you're fiber poor, so to speak, or relatively speaking, not fiber rich, you have no choice. But the simplest technology for PAM4 that will always work is just parallel, right? Basically DR8. So if you have enough fibers, you can run that 10 kilometers all day long. If you have to go FR4, you're looking probably at 2, 3, 4 kilometers. And there's some new polarization schemes where it may go to 5, 6, 7. But again, the vast majority of traditional data center applications can be met with PAM4. So the real opportunity is beyond what PAM4 can do, which is a large and growing market.
And the next two questions are from Silicon Photonics Foundries, one on thin film lithium niobate, and the other one, actually, the second one is on indium phosphide. But the first one, let's go to Switzerland to meet Amir Kadini, the CEO of Lithium. Amir, welcome to the meeting. Tell Andy and me, what's on your mind?
Yeah, thank you. Hello, Andy. Can you hear me, by the way?
Yes.
Loud and clear.
So a quick question. So, so you covered really nicely about the sort of different aspects of the DSP. So actually, I wanted to ask you about sort of what you think about the difference between the differential drive, like for GSSG, which is for silicon mostly, and the GSG, so let's say single drive. Do we see any a power, let's say, the cost that you pay, or maybe some other thing, between these things? But there's a huge debate that maybe single drive is not going to make it because of some technical limitations.
Yeah, I'm actually not the expert here, but my observation would be that whatever driver chips people are developing for either the LPO or LRO or any kind of optics are designed to handle any kind of modulation technology. So naturally, they're differential output. And then it comes down to, can you go to lower power if you do differential, or you get a better signal? And that's really within the optical engine. So the end customer doesn't see that, right? All they care about is the performance that they get. Going back to my earlier point on thin film lightweight, I think the current view is that the advantages of thin film lightweight are much bigger in the 224 gig generation, where silicon photonics is kind of running out of bandwidth. It still performs well, but thin film lightweight performs better, right? And then also the power savings are more significant there. So I think that the window for thin film lightweight is, in my mind, is 224 gig PAM4.
Thank you very much, Amir. And Amir loved your answer, by the way. And we continue. Another question comes from Canada, the Canadian Photonics Fabrication Center, CPFC. Daniel, welcome to the meeting all the way from Canada. Tell us what's on your mind.
Thanks. Thank you, Andy, for the excellent presentation. My question is going back to the coherent linear receive optics. So in traditional coherent optics, you have a local oscillator on the receive side, and the DSP does a lot of work in matching that local oscillator to the signal. When you pull the DSP off the receive side, what happens there? What are the problems with having to do that phase matching?
Well, you're talking coherent now, right? And there's one startup, and I forgot, out of Santa Barbara, I forgot the name now, that is trying to productize their DSP-free coherent optics. And you know, if that works, that's great. So there are perhaps ways to simplify the whole operation of coherent in the context of a data center reach. And this may take off. I mean, that's, again, the beautiful thing with optics is there's always new innovation and great ideas how to make it even better. I don't know much about this particular startup. In fact, I can't even recall the name. I apologize here. But there was some OFC presentations from UC Santa Barbara on that topic over the years, and there's certainly early demonstration. Now, the negative is you're putting all the performance on the optical subsystem, right? So that has to be implemented in a very, very good way to deliver the bit rate. And the DSP, of course, then has to be able to recover that. I'm sorry, the main service.
Thank you very much. I had two more questions for you, and this will be the final two questions because we need to move to the next speaker. The first one is coming from the McGill University, the group of David Plant. David, you're watching this. Hello, great to see you. Great to see your colleagues here. Benton Q, what's on your mind?
Hi, Andy. Thanks for the great presentation. I was wondering, when we talk about no DSP, are we considering pulse shaping in that?
Pulse shaping.
Yeah, well, there's no, in a linear optics, it's linear, right? There's no other shaping. All the work is done by the DSP in the switch chip. So the reason the performance is so good is that those DSPs are digital. They have lots of tabs. They're actually better than the DSPs that are generally in the optics module itself. Now, they have the overhead, of course, of the electrical channel, but again, with 20 plus tabs, you can do an amazing amount of recovery. The reason these DSPs are as good as they are was they were designed to handle copper cables that are also kind of a very poor channel. But it turns out the same benefit accrues to a combined electrical trace and an optical trace as well. So the DSP is whatever it is, and all the magic there is what Broadcom and NVIDIA and Marvell and so on do in their DSPs. And it's really that performance that enables the end-to-end channel. So does this answer your question?
It answered my question. And now with the final question of the series, we go to the next speaker who has a question for the first speaker. Mark Lukovic, CEO of Five Reality and a very respected person in the photonic industry, has a question about polymers. Mark, speak your mind. You always
Yes,
do.
Andy, what is a realistic timing for organic polymers as a material, would you say?
I have no idea because I'm actually not that involved in the most advanced optics technologies. Our job at Arista is to bring things to market that we can ship next year, and we'll test those modules when they arrive. But I truly don't know when they happen. I do have one last comment though, that there is no emerging interest in 448 gig PAM4, believe it or not. Which initially would require DSP, of course, to encode it, but the belief would be that it's lower cost than 224 because it's half the number of channels. Now, for 448, you would need very high bandwidth. And one of the few bandwidth things that can do this is, of course, thin film light gate and the polymers. So there may be another opening in the 448 generation. But realistically, we're talking, I don't know, 27, 28, 29. So this is several years in the future. But the world does not end at 224 gig. I just want to make that clear. And whereas silicon photonics bandwidth most likely will end at 224 gig. Okay.
So the good thing of this meeting, this is not a webinar. This is a group of people who want to talk to each other. Mark asked for a realistic time for organic polymers to be available and mature.
Yeah,
Louis Johnson from NLM Photonics.
But let me say this differently, right? In the end, what drives adoption of newer technologies is that the existing technologies no longer can do it, right? So it is true that in a 448 gig world, it's game over for, I think it's game over for silicon photonics. And then there's a question of what else actually works. And we'll see.
For those of you who are in YouTube right now, you can go at any time, search for Andy Bersosheim, right technology at right time, and watch that video because it's fantastic. But before that, Andy, there is somebody who wants to answer Mark's question. Please tell us from NLA Photonics views, what's in your mind? When are we going to have available at industry-ready organic polymers for silicon photonics?
Yeah, thank you, Jose and Andy. So as was mentioned, this is going to depend on ultimately customer needs, and I agree that there's opportunities at both the 224 and 448 bandwidths, but the realistic timeline with depending on fab adoptions, probably sampling 2026-ish and broader availability 2027, 2028.
We're going to organize a meeting in 2 years for you, Lois, to show us in 2026 the maturity of organic polymers. It is great to have you here. Luis, you actually brought one slide to the meeting. Now is the perfect time to share it with the world before we give the floor to Mark.
All right. All right, thank you, Jose, for the introduction. So as Jose mentioned, Louis Johnson, CTO of NLM Photonics, and our focus is on extending silicon photonics for the linear drive era using hybrid organic modulation, which can take advantage of low power linear drivers and particularly reducing the power use and providing good modulation depth on the transmit side with very high extinction ratios, low insertion losses. And this can provide, along with technologies like thin film lithium niobate, this can provide a further power savings beyond the linear driver alone. We have some modeling data from work that we've been doing with NO recently, showing a further 10 to 40% reduction being possible above and beyond the linear driver reduction, and with a path to further improvement as the organic materials are further optimized, which is a advantage of organics, is that there is a substantial parameter space for further material improvement. And the advantage of this technology becomes even larger at 200 G per lane or 400 G per lane. And another recent development here, and some of this was discussed in some work co-published with the Carlsbad Institute of Technology at ECOC, is organics are now able to survive up to 120 degrees C long-term stability, which has represented a substantial advance for being able to bring them closer to electronics for data center deployment.
Thank you very much, Luis. Congratulations on your work that you're doing with IMEC and with AIM Technologies. We want to try your stuff. We want to test your stuff. I want to see it in other laboratories. When can we access it and how?
Yeah, thank you, Jose. So at this point, yes, feel free to contact us, and we are working with a couple translational research fabs. AIM's probably the furthest along, but we are happy to partner with optical module developers and other fabs. We have several other relationships underway there, a couple of which Jose already mentioned. And and even for academics, we can provide samples and willing to work. But our focus at this point is moving this technology from the small scale area where it's been at the die level towards wafer scale, fab scale deployment to provide efficient modulation for commercial linear drive optics.
So contact them and you can use their polymer. Luis, congratulations on everything that you are achieving. And now it is time, all of you, it is time to welcome our next speaker, a person who has been very controversial and we all admire and respect. Mark Lukovic, thank you very much for being with us today. The floor and the attention of everyone goes to you. Do you like linear drive optics?
I can't say it's my favorite subject, Jose, but you probably know that. So let's see, I need to, here we go. Yeah, I mean, there has been a precedent for linear. 20 years ago, people are still recovering from the battles in dealing with a linear situation. I mean, this sort of thing was ignored in the whole discussion of the narrative, unfortunately. I know recently Cisco has put out something publicly where they claim that the ACO they were dealing with a half a decade ago may have had a problem with the linear interface. I think that's it's a little bit historic revisionism, but you know, to the extent that you know they were willing to argue that, it would have been helpful had Cisco mentioned that a little bit earlier. Basically, you know, the fundamental problem here, unfortunately, is that we needed to address these matters a lot earlier. You know, when we were contemplating PAM4, we were contemplating jumping to 400 gigabit Ethernet before having to reverse on standards to 200 gigabit Ethernet. You know, contemplating strangleholds and all these sorts of things that have happened. You know, the power, the cost. But once the PAM4 horses left the barn, that is the wrong time to be addressing these things and punishing suppliers, you know, like Marvell, you know, after the fact, you know, and you know, kind of implying that you know, maybe there's no need for these DSPs. I am watching my time, Jose, I promise. Very, very quickly, what hasn't been addressed is just the age-old arguments that we've had with centralized versus distributed types of processing. And it isn't, you know, it's totally ignored what would happen if we went to a centralized approach with these LPOs. What you're doing is you're just transferring the power and all that complexity to one place. And I'm not sure that's what we really wanted to do. You know, I think Andy reflected on this. You know, basically, you know, this solution of half retimed that's been available. It could have been talked about, you know, a lot sooner. It should have taken a year of industry resources being used and that sort of thing. You know, the fact of the matter is, yes, there were interoperability displays at OFC, but how many of them were fudged? And I don't mean to, you know, suggest anything untoward, but you know, I think a lot of suppliers felt they needed to show this because that's where this convoluted rhetoric was going, even more convoluted than co-packaged optics. And really, if you would have, you know, Google has the most you know, influence on optical development of the hyperscalers. They knew in March of 2023, based on their own analysis, based on their own experience, and not on the demos of a few links. They knew you could not do 200G plus, not to mention even 100G. It's somewhat problematic. This sort of thing should not happen in our industry. It makes us look bad. It's a hard enough industry, and you know, we have to be careful about these things. And so, you know, Halo, I don't know, you know, I guess I'm hearing that Halo is not as good, or, you know, half retimed is not as good as linear pluggable. But I don't know, some of the feedback that the OAF is getting, you know, it's kind of in the ballpark on power and cost, you know, so I don't know what we're talking about. And yes, it is insulting to technologists. It's, you know, the idea that you're going to tell designers and technologists that there's no purpose for a DSP and you could just remove it. You just remove it. It is just one of the most, in my 40 plus years of experience, you know, one of the most idiotic ideas I've ever heard. I'm sorry to say that, but you know, I have to express my point of view. Yes, NVIDIA could do it just like they could do co-packaged optics. The AOC portfolio, we'll have to see where that goes. but essentially, this is something that never should have happened. It's a total embarrassment. Thank you so much.
Thank you very much for a great presentation, Mark. I enjoyed it very much. What do you think of Kobo? No, I'm kidding. Are there any questions? Are there any questions for Mark Lukovic in the room? Puya, the floor and the attention of everyone goes to you.
Okay, thank you, everyone. So I would like to introduce our next speaker. Actually, it's a very exciting company that does great things. Without any further ado, I would like to invite Ron Schwartzentruber from Lightelligence. The floor is all yours.
Okay, thanks, Puyo. Let me get started here. All right, am I sharing the right screen?
Yes.
Okay, perfect. So thanks, Puyo, for the introduction. My name's Ron Schwartzentruber, Director of Engineering for Lightelligence. Lightelligence was founded in 2017 to develop and commercialize photonics technologies for groundbreaking improvements in computing solutions. And one of those is linear drive optics for PCI and CXL applications. So I'm going to share a little bit about that in today's presentation. And we go to next slide. So here's the agenda. We'll talk about how linear drive optics is superior for scaling. We'll get into optical CXL as the emerging standard. We'll talk about our case study, how we proved it to ourselves, and then we'll discuss a little bit about the active optical cable. Okay, so first of all, what we're hearing from all of our customers is that they do not want to pay the penalty for the retimer. They don't want to pay the power penalty, and they don't want to pay the latency penalty. And what you can see here is that the linear drive is excellent for scaling. The signal loss in copper is quite high, even over short distances. So what you generally find is that at 10 meters, it's really done. And even at Gen 5 and Gen 6 speeds, we're looking at maybe 2 to 3 meters, even with active cables. So to really get across the rack, you're going to need optics. The other thing we're seeing is that PCI, or the phi latency, right, is dramatic for Ethernet. It's got the built-in FEC versus PCI 5 is no FEC, and in PCI 6 there's a lightwave FEC, so it's slightly higher latency, but overall, it's a consistent low latency versus the dramatic high and variable latency of Ethernet. Furthermore, the cable cross section, you can just look at here, your copper cables are very bulky versus your optics is incredibly small. This was an example using a single wavelength, but once you add in multi-wavelength, those cross-sectional diameters go way down. So let's talk a little bit about optical CXL. So CXL is the emerging standard for memory disaggregation. It adds cache coherency and memory functions to the ubiquitous PCI interface that's dominant, the dominant load store interface that's used. So CXL is a perfect solution for memory disaggregation. It's a perfect memory interface. And what CXL over optics will do is allow you to go across the rack. So you can have your compute, your GPU in one rack, you can have your memory in another rack. They can be interconnected by series of switches. And it really enables this memory disaggregation. And our CXL over optics provides low latency, high bandwidth, and a data center type of reach. So just a quick case study. So we've demonstrated this at the Flash Memory Summit last year. We won Best of Show Award. We're the first company ever to demonstrate CXL over optics using a PCI Gen 5 solution. And what you can see here was we had a super micro CXL enabled an AMD Genoa CPU on one side with an NVIDIA A10 GPU in the server. And what we did was we compared storing the large language model on the SSD memory, on the same server versus moving that memory to a CXL memory expander that was on the memory expander box, which you can see on the right. And so in this case, we put the large language model, 10 meters away. And in fact, the decode throughput of the model was about 2.5 times better. You can see the results here. And so we were running OPT 66B, which is a smallish model, but it was about 120 gig. So it fit on a single memory expander. And we did news text summarization, and sure enough, it was 2.5 times faster than disk. That just shows really the advantages of CXL, compared to NVMe, with all of those results here. And so what we're showing here is our linear drive CXL PCIe Express AOC. So today, the PCI Express copper cable standard is CopperLink, and we've made some enhancements to that spec to be able to support linear drive optics. And so that spec, you'll see CopperLink 1.0 being released shortly and being advertised. It'll support copper cables as well as active optical cables. And so be a perfect way to have a compliant PCI CXL active optical cable. What's being shown here is the CDFP style 1. So it supports CXL 2.0 PCI Gen 5 by 16. We have a proprietary sideband over optics protocol, so we can transmit all of the needed sideband signals across the optical cable. So using a multi-mode fiber type of solution, we're getting up to 30 meters easily. We've actually had some tests with 50 meters as well, and even 100. So we can really push this as needed. The end-to-end latency, you're really limited by the time of flight. It's it's a linear cable, so it's 1 nanosecond plus time of flight. And so therefore, most of these applications are in the 10-meter range because you're talking about, they still want the low latency from the GPU to memory. I mentioned power is a big concern. The customers don't want to pay the retimer power penalty. So it's, we're less than 12 watts per connector. So what we're interconnecting here is CPUs, GPUs, switches, and obviously all of the various endpoints, the memory type of endpoints. We're actively working with the PCI SIG and the optical working group to define additional optical cable based standards, and those include QSFP DD and OSFP XD. And we'll be right there to help advance the state of the art in the standards. So that's the end of my slides, and I'd be happy to take any questions.
All right, thank you so much, Ron. The questions are coming through, but before I get to them, I want to ask you the Optica question. What can you do for others, and what can others do for you? There are lots of folks in the room that I'm sure are eager to collaborate with you, so they need your insight to know how they can help.
Yeah, how they can help is really, I think, get involved with the standards organizations and really help us break sort of the technology wall where folks are looking for optical solutions. They're looking for, okay, how do we get beyond copper. So there's many companies now offering solutions, and I would just encourage you to join. There's a short reach optics group within OCP. I encourage you to join the CXL consortium, and as well as the PCI Express optical working group. Get involved and really help the industry move forward.
Okay, I have a question. Let's go to my friend Fernando Gomez. Fernando, why don't you put yourself on, unmute yourself and tell us where you are and ask your question, please. And we'd like to see your face as well if you have your camera on.
Well, you can see my face, but if you want to hear my voice,
sure.
The question is fairly simple. PCI SIG has, for the longest time, not really committed to an optical interface other than just a pure E to O and O to E. But with the, the emergence of shorter link optical links inside the data center, and of course with CXL as a competing protocol, if you will PCI SIG eventually adopt, perhaps after Gen 6, will they adopt an optical interface? And what are the implications for vendors? And part of it you already answered, that you're involved in the standards, Ron, and that is so the direction that appears to be taking shape. But in any event, what's your view on that?
No, that's a great question. So for the last 6 months, they launched an optical working group to specifically address that. And there will be an ECN to the Gen 6 specification to define optical retimers. And further to follow that, they will be defining connector standards for optical cables. So this is coming, and I think what the SIG, at least what we've heard from the SIG, is they've agreed that it's going to be needed probably starting in Gen 6, but then more prevalent for Gen 7. So the solutions that we define in the ECN and in the Gen 6 and 7 specs, will need to sort of pave the way for Gen 7, Gen 8.
Okay. What about things like link training and state machine status and things like that? Are those things that would also appear in optical form, or will those remain in the?
So no, that'll generally remain in the root complex endpoint or switch, but what they are defining is this notion of an optical retimer, where in the case of a retimer, there is the link training state machine in the retimer itself. So they're basically enabling or adding an ECN to say, okay, now that we have an optical interface, what changes do we need to make to that training state machine? So that'll be part of the ECN that you see from PCI Express that'll be released this year.
I see. Well, that's an add-on to already existing electrical retimers, anyways, right? So
correct.
Yeah.
All right. Let's. I will bring into a couple of more questions. The first one from my friend Deepak Chudasama from Trump. Deepak, why don't you unmute yourself and ask your question?
Yes, thank you. Just a simple question, I guess. This is an AOC, and I wanted to understand if there were any special requirements for VCSEL for these AOCs.
Sorry, any special requirements for what did you say?
For VCSEL, for the laser.
So no, this is a multi-mode application, so simple, VCSEL driver TIA type of implementation. So anywhere, and the reason this was chosen is it's a highly reliable technology. It's basically proven in the Ethernet market. So no, there's no specific requirements on the laser.
Okay, thank you.
All right, thank you so much, Ron. Actually, the next question is from our next speaker, from Rohin from Lightspeed Photonics. Rohin, why don't you ask the question from Ron, and then I know you also have one slide, then we can start. You can share that one as well. The floor is yours, Rohin.
Yeah, I was originally thinking that this is a silicon photonic solution. Now that you clarified it's pixel based, what wavelength is this? AOC?
Yeah, so this is based on like standard, as I said, VCSEL technology, and we do have single mode solutions as well. So this particular implementation, we believe we're using the standard 850 type of implementation.
That's interesting. Thank you.
All right, Rohin, why don't you share your one slide and tell us what you do and what you can do for others and what others can do for you.
Absolutely. Hello, good morning, good evening, everyone. I'm Rohin from Lightspeed Photonics. At Lightspeed, essentially, we are building linear drive optics as a near packaged or onboard optics solution. Unlike the expensive socket-based onboard optic solutions, our product Light Connect is built as a surface mount component, so it can be soldered near the ASIC, avoiding the long transmission lines, which are basically the ones that you want to avoid for lots of signal. Designed for both free space and pluggable fiber compatibility, multi-mode fiber for legacy compatibility. Light Connect essentially is as bare bonds as it gets, like a physical layer interconnect. It has a driver, TIA, and you're looking at with a VCSEL array and a photodetector array, combined with our custom micro optics design. All of it is packaged in a 7mm by 4mm LGA package. For short range within the server chip-to-chip communications, we collimate the beam to sufficiently large diameter to get easy alignment of free space connectivity up to 200 millimeters. And you can see the solder components on the test board on the left here. And we are also building an easy to integrate multi-mode fiber version of this that is compatible with the standard MTP MPO connectors. And as some of the speakers spoke about, it is built on proven reliable components, essentially VCSELs in the drivers, and simplifying the high-speed design for our customers, providing up to 68% reduction in power consumption compared to the regular pluggables. And it is integratable as a surface mount standard assembly process and provides a protocol agnostic 5-layer connectivity to run any standard protocol based on LVDS like PCIe, CXL, or standard optical Ethernet protocols. We are gearing up for commercial deployments as early as next year, and we have a roadmap for 100G per channel and 200G per channel as a development with the partners who are supporting us. Please feel free to reach out if you find our tech interesting for your applications. It's extremely compact form factor. You can put it near the package or the board. Yeah, that's from Lightspeed.
Thank you so much, Rohin. And just a reminder for everyone: if you want to get connected to anyone in this meeting, just feel free to reach to any of us at Optica, and we'd be happy to make the introduction. Now, with that, I would like to actually introduce our next speaker, which has an interesting technology for us. It's Nubis Communication, and the speaker is Son Lei. Son, the floor is all yours. Please share your slides, and we are all ears to hear yours.
Hello, can you hear me?
Loud and clear.
Yes, thank you very much. Let me share my slide. Okay, so basically in the presentation, first of all, my name is Son Lei. I'm from Nubis Communication. And in the presentation, I would like to talk about some important prospect of linear drive optic for 100 gig and 200 gig. And here, I would like to broaden the discussion a little bit to cover various implementation scenario for linear drive optics, including CPO, NPO, or LPO. So first, I want to express our view. We believe that linear drive optic is a very elegant technology to increase the I/O density beyond terabit per second per millimeter, and to reduce the power consumption, reduce the latency, reduce the cost, while increasing the implementation flexibility for high-speed optical interconnect for data center and for especially for machine learning and AI application. So what you see here is Nubis 1600 16 by 100 or 1.6 terabit per second full duplex capacity linear optical engine in very small form factor. And our unique vertical fiber array attached approach allow for the optical engine to be placed in multiple rows around the ASIC to achieve terabit per second per millimeter of I/O density with very low latency and low power consumption below 6 picojoule per bit, including the laser. And in general, the optical engine is designed for machine learning and AI application, but we also have the different form factor which allows it to be placed in the pluggable module as well. So in the presentation, I would like to present some measurement results about the performance of the optical engine in the linear drive application at 100 gig. And I'm going to discuss also its scalability to 200 gig. So you see here the basic schematic of the experimental setup. We use here a commercially available 51.2 terabit per second switch with 100 gig LR circuits. And we connect, we use a host compliant board to connect the switch to our XC1600 evaluation board. And you can see here the channel, including the packet channel, the PCB on the host connector, and through the host compliant board, and also through our IF cable and our socket and the channel on our evaluation board. And then the optical channel here is optically looped back. Okay. So you see here two measurement set of results. The blue circle is the prefect PR versus channel loss from 10 to 22 dB when we switch off the analog equalization within the optical engine. And the red square here, curve here, is when we switch on analog equalization within the optical engine. And you can see here that by switching on the analog equalization, we have a much higher, better performance. And this is our first generation of analog equalization. And for our production revision, we have implemented a much better, stronger analog equalization with more boosting. And we could achieve a much better performance, a more than order of magnitude performance improvement, especially as a high channel loss. Okay, so just to remind you, so for the popular use case of LPO, NPO, or CPO, we have typical performance expectation as 1e-8 prefect PR to cover 20 dB loss, 15 and 10 dB loss. So now, based on that typical requirement, you can see that when we don't have the analog equalization within the optical engine, we can only support the CPO, but LPO and NPO applications seem to be difficult. With our first generation of analog equalization, we can reach 17 dB of loss at the BR 1e-8, so we can support CPO, NPO, and most of LPO. For our production version with what we call advanced analog equalization, we can reach 22 dB of loss at the 1e-8 BR, so we can support all of the applications. And the cost of advanced analog equalization is actually quite small, only 0.8 picojoule per bit or 0.6 watt per 800 gig. And it is significantly lower than a typical 7 watt power consumption of 800 gig optical retimer. So the message here is that for 100 gig, strong equalization, analog equalization enable all the applications K from CPO, NPO to LPO, and did it at 100 gig. So how does it scale to 200 gig? So let's start with 100 gig case. We have here again the prefect PR versus the channel loss. And for 200 gig, our analysis shows that we're going to have the 2 to 3 dB SNR penalty. And with the good implementation, in our case, with the different design for driver TIA, we believe that we could achieve 2 dB penalty. And then you end up with this curve here for 200 gig. So now for 200 gig, now within the discussion within OIF, the bar is quite high. For the LPO application, now we need to reduce the threshold for the PR probably to 1e-6 is our assumption. Then the typical implementation for the channel loss can go up to 27 dB or even higher. For NPO, CPO, the channel loss could be reduced to 20 to 15 dB. So now 27 dB is very high. So it means that it seems to be difficult to achieve the desired performance at the channel loss. But for CPO and NPO, for 20 dB loss, it is possible. So now if we want to scale the 200 gig linear direct drive for LPO application, we need to reduce the channel loss. And it could be done through using either flyover cable or VLC. And with that, we believe that the channel loss can be reduced to around 18 dB, and this is possible. So, and we believe that it is a way to go. So the message here is that strong equalization is needed at 200 gig, and it's going to be enable linear direct drive at 200 gig for NPO CPO. For LPO, probably flyover cable or VLC is going to be needed. So here's my summary for the case of 100 gig. We believe that with analog equalization, with a well-designed analog equalization, we could support all applications, all the use cases from CPO, NPO to LPO. At 200 gig, it's going to be challenged, but CPO and NPO with advanced equalization is possible. For LPO, we need to reduce the channel loss using either VOC or flyover cable. But the bottom line is linear direct drive appear to scale to 200 gig with advanced equalization. And with that, I would like to thank all of you for your attention.
Thank you very much for a great presentation, Song. My regards to all your colleagues. You're doing a fantastic job at Nubis Communication. We are really amazed.
Thank
What
you
can you
very
do
much.
for others? What can others do for you? What are your key challenges at this moment that companies can help you with?
Oh, so basically, I think I agree with Andy that the big challenge for LPO is to have the test platform so the customer can test and be confident about the product and especially interoperability testing. So having the procedure to be compliant at TB2 is important. And with that, we also working on some advanced feature within the driver to enable the TP2 compliant.
Thank you very much.
Yeah.
So we have a few questions for you in the room. The first one is coming from Mark Lukovic. Mark, what's on your mind?
Yes, hi. I wanted to ask you, your most valuable solution is the vertical line card, which is going to enable pluggables indefinitely and,
Yes.
and remove your discussion, remove the discussion about CPO and NPO. When you guys going to start talking about that solution that's your most valuable asset?
For the VOC, so actually I'm not sure I'm the right person to answer the question, but for sure VOC is very important, especially at 200 gig, and also we're working with a few partners to push it forward in the stand-up licensing and in stand-up designing pluggable for that. So it will come at the right time. That's all I can say. So
that's perfect. At the right time is the perfect answer for Mark.
Sure.
The next question, Song, is coming all the way from the UK from Juan Vaya, designer of electronics. Tell us what's on your mind.
Hello, just a quick question. So when you say analog EQ, do you mean just a standard CTLE with this?
Yes, thank you for the question. So there's a few, we have a few, it's a CTLE plus picking, and of course we have some special design in our case. So yes, unfortunately I'm not an IC designer, so that's all I can say.
Sure,
But Suhas is an IC designer, so please make sure you follow up afterwards. The next question is coming all the way from CMC Microsystems. Ahmed, all the way from Canada. Tell us what's on your mind.
Yes, it's actually about because I think you mentioned the test, like the customers to test their modules, right? Like, have you done any yield analysis? Like, because when you are at the production, like volume production, right? You're supposed to have like yield analysis, so customers know, you know, what's your yield, what's the cost, all that information is very important, right?
Yes.
Rather than, you know, let the customer test, right? So what are the yields look like for this technology that you're offering?
Yeah, so basically we have a good yield for the silicon photonic IC. For the analog IC, the yield is very, very high. It is based on silicon germanium. The yield is very, very high. And for the packaging and the fiber coupling, so we're working to improve the yield, but the yield going to be as good as the yield of silicon photonic IC. So overall, we are quite confident to deliver the product in the mass production.
Yeah, but
So-
sorry if I wanna understand the. So you have the yield, like, do you have a number, and then you have the accumulative yield, right? You have to be at like 99%, right? Because you have many stages, right? And each stage will actually lower the yield, right? So
That is true, but we have a few key components here. We have the photonic IC. Of course, there's many components integrated in the single IC. For the analog IC, I can tell you that the yield is close to 100%. For the photonic IC, then we are improving the yield, and it getting that. And for our fiber attach and packaging, and then yield keep improving. So we are improving the yield every day.
okay, thanks.
Thank you very much, Son. There are three companies who want to introduce their technology to you and to the rest of the speaker. We're going to start with one company who may help you improve the yield. We're going to Keystone Photonics. Philip, thank you very much for being with us. Please share your screen and tell us what you can do for others and others can do for you.
Yes, thank you very much for introducing me here. So we have heard a couple of times that that LPO puts a lot of heavy weight on the optics. In the DSP world, well, things are rather soft, but if you leave away the DSP, then things get heavy on optics. And we heard that a couple of times, and he was phrasing it that he doesn't want to be the company doing the optical qualification. We heard it here. Nubis is moving the yield up, but I think what is always has to be done if you move yield up or you're looking at yield is testing, and that is what Keystone Photonics does. We provide products for optical testing. So how we do this, we have industry-proven products for test and measurements. We have the optical probe test. For that, we take fiber arrays or other photonic components and we 3D print a micro-optic structure on it. We have extremely high precision alignment. We have very good beam shaping because it's created at the place where you need it with high-resolution lithography. We use machines from Vanguard Automation, and with that, we achieve super low variation. Now, how that can be used, it's used for wafer level testing mostly and module level testing. So we're capable of creating probes for probing through grating couplers, or we can create probes that go into edges of wafers, and that allow to qualify your components at wafer level. We can do the same thing also on module or assembly level for testing optical lenses. We can tune the mode field of 3D printed fiber arrays and mirror lens fiber arrays to anything between 2 and about 40 micrometer, and that really allows you to test your optical components in a manufacturing settings. So we're in manufacturing in many silicon photonic fabs now. We collaborate with most of the photonic testing companies, so we're ready to support you. Thank you.
Thank you very much. The second question who wants to also help you here, Song, and the rest of the speakers is the company that is actually sponsoring the event today. Thank you very much, Ajinomoto, for being with us today. Nakahara-san, the floor and attention of everyone is yours.
Okay, thank you so much. Can you hear my voice?
Crystal clear.
Okay, thank you. Just I will introduce our company profile and our materials. So can you see my slide?
Yes, but please go presentation mode.
Nice, okay.
Control L.
Control A, sorry.
Yes, it's good enough.
Yes. Okay. So let me introduce our company profile. Thank you very much for opportunity. So my name is Yuichi Nagahara from Ajinomoto. Ajinomoto is known as a food industry company, and also we supply the electronic materials such as called Ajinomoto build-up film called ABF. ABF is initiation materials used between build-up substrate layers. ABF has a now is one of the de facto standard materials for semiconductor manufacturers. So just now, we have several lineup for co-packaged optics. So one is polymer-based optical waveguide materials called KT series. Just we supply several materials based on photolithography technologies. And just now, we can achieve the core materials with achieve a single mode optical transmission. And also another is adhesive materials called plain set, such apply for adhesion for fiber and adhesion for fiber, optical fiber. So just please, if you interested to our materials, please contact this Ajinomoto Fine Techno USA, Habib Hirsch. Thank you so much.
Thank you very much, Nakahara-san. Ajinomoto being one of the sponsors today. And the third company, Son, that wanted also to speak after you is a company means a lot to Optica. We're going to one of the leading suppliers of design suites in the Optica membership, OptiWave. Thank you very much for being with us today. Tell us what's on your mind and tell us how others can help you and you can help others.
Sure.
Please go presentation mode.
Thanks, Jose. Hello, everyone. So yeah, I'm Ahmed Atiyah. I'm VP at Optical System at OptiWave. OptiWave is a software company. We are established like about 30 years ago. So we are a long time in the business of designing software packages used for designing photonic components and systems. We have, as you see here, 8 packages of software: OptiSystem, OptiSpice, which is an OptiFDDT. These 3 software can be used for designing the transceivers, basically. And we have in OptiSystem software over 600 components and visualizers, which can be used for simulating the different devices and parts in the transceiver. We have a capability to operate our software with external software like Python or MATLAB or Scilab. And also, we have a huge library of examples which can enable the users to kind of start his simulations for the different system levels or device levels. If you are interested in downloading our software, you can go to OptiWave website and you may download 30 days of free trial of any of these software packages. We'll be very happy to work with you on setting up your design and maybe if you need any help in simulating your transceivers. Thank you.
Thank you very much, Ahmed, for all the great support that OptiWave has been given to Optica. It is time to give the floor to our closing keynote speaker. I'll go to a company that many of you visited during OFC because they had an LPO demo for everybody to touch, and they're actually working with OIF on standardizing the interconnection. I'm going to give the floor to Tiger from Axelink. The floor and the attention of everyone goes to you. You are our closer. Enjoy.
Right, thank you, Jose and everybody. Axelink is manufacturing and also developing LPO and ARO modules right now. So I'm going to share a little bit of results from our very preliminary test and experiments and simulation to validate some of the points that Andy brought up. But before jumping into data, here are some summary of the LPO benefits. Lower power, lower latency, module cost, and reliability. And today I'm also going to touch base on the heat generated from the module and also overall switch system that will also impact to power and reliability. So this is the demo summary from OFC that Jose just introduced. We had the 64 by 800 gig switch from Wistron, having our 800 gig DR8 and 2 by FR4 modules demonstrating the TP2 eyes and also PER. Just to clarify, these modules are based on silicon photonics, and we were comparing with LPO, LRO, and DSP-based modules, and all of these are working pretty good. And also, we had the line coming from OIF booth that's linked from their NPO signal, and we are receiving pretty good way as well. And furthermore, we did continue our experiment by doing some simulation and also experiment, filling up all the 64 ports with DSP and LPO modules. And to manipulate the results, we fixed the fan speeds. And this particular data is showing the speed at 75%. And the x-axis is showing this switch port counts. And also total switch is y-axis. Just because we fixed the fan speed at 75%, we only saw 20% power difference. However, this is going to relate to the next slide. Just to clarify, this is a DR4 optics, a DR8 optics. Left-hand side is another chart matrix. Of the x-axis, we have the switch overall power consumption at 64 channels. With the DSP and LPO running. And y-axis, we have the switch temperature. And we plotted the data from when we measured the overall power consumption and temperature at the fan speed of 50%, 75%, and 100%. And of course, the difference is relatively similar to the previous result, 20%. However, you can see the significant lower temperature with the LPO. And of course, this is a temperature power matrix. It cannot be linear, but if you have the linear line like this on the left-hand side, we can expect to reduce the fan speed. Probably that will contribute to good amount of the power reduction. And I'm pretty much supportive of what Andy said, 40% of the system power consumption reduction coming from not only the power consumption at the LPO, but the cooling system is going to be more efficient. And relating to this temperature topic, Makeup gave a presentation at OFC on the reliability and presented that the LPO compared to DSP-based module has a 3 times better reliability coming from the heat. So we're hoping to further experiment and develop our LPO module to elaborate these features. And lastly, this is the average module power consumption of LPO, LRO, DSP. These numbers are matching what Andy presented. I didn't have too much about LRO, but we are working on it. But like Andy mentioned, LPO MSA having industry leaders working on the specifications, probably coming around the Q3 this year. So hoping to have more data compliant to MSA specification later on. Thank you very much.
Thank you very much for a great presentation, and thank you for the collaboration that you are doing right now for the entire benefit of the industry. Tiger, what can you do for others, and what others can do for you?
Sure. Like I think Sam mentioned, but yeah, we like to have more partners to verify modules, but also to further have the efficient modules, we probably would like to hear what are other technology enablers to lower the power consumption. So we like to hear from components manufacturer to further enhance our modules.
I would like to remind everyone that this was an online production. The meeting will be on YouTube for everyone to follow. I'm going to give the floor to our closing question before we close the meeting, and that has the honor to be Winfred Knoll from Focuslight. Winfred, ask away for Tiger from Axelink.
Hello, Tiger. Good to see you again. So it's very interesting. When I'm looking at your presentation, I like to know, so you provide now an LPO model. So is that more a pull from industry, from companies like companies to deploy your products, or do you see also from a production point of view, it makes more sense to go into the LPO direction? So you like to push it a little bit more. So is the way pull push, is it more on the push side or more on the pull side? How do you see that?
This is my personal opinion, not Axelink or I represent anybody, but hearing from the very broader view of power consumption to add AI cluster and machine learning things, do we have enough power to support in general, like like a data center, especially Japan is having data centers, hyperscalers or big ones in one area. And if we are adding these new features to the data center, I don't think power generation is enough in the area. So it's, I think personally, pull technology to enable or to have our life better, I think.
Thank you.
Thank you, and thank you, everyone. It is 5:30 p.m. in the Netherlands, 11:30 a.m. in Washington, D.C., and 8:30 a.m. in California. This meeting was global and produced by Optica. I would like to thank all of you for the great presentations. Remember, everyone who has been registered will receive an email asking them to join Optica as a corporate member. Please do so. We need your support. If we like what we are doing, if you like what we are doing here, the only way for us to keep our jobs is to become corporate member of Optica. Otherwise, we will be sending you our CVs to work for a corporate member. Thank you very much, all of you, for a great event. And thank you, Andy Bergosheim, for being with us today and setting up the scene. Myself, I'm a believer on LPO. You can quote me on that. Take good care of each other. Wash your hands. No, it's not pandemic anymore. Enjoy the relations. Enjoy and see you very soon. All the best. Bye-bye.
Thank you,
Thank you, everyone.
Thank you. Bye-bye, everyone.
Bye-bye, everyone.
Bye.
Bye, everyone.
I would like to ask now my IT department to cut the YouTube stream. Please. Whoever needs to go, please feel free to go. Whoever wants to stay now and chat with everyone, you can stay. The meeting has become now a private meeting, and do my tie. So all of you are welcome to stay now and have an open discussion. Mark Lukovic.